All right, and we are back. All right, hopefully everybody is off spring break now, or at least getting off and getting back in the groove of things. If you remember, I told you at the beginning of the semester we don't want to miss class unless the sun is out, the fish are biting, and the beer is cold. Unfortunately, we have to miss class for the virus, okay? That's just the way it is, but we're going to keep trucking along, right? We're going to get y'all through this, all right? And it's a learning experience. We all got to adjust. We all got to learn, and we're just going to keep trucking along. Chapters 12 through 16 are already posted on YouTube, so go ahead and start looking at those. And preparing, you can look at them as many times as you want. That way you can take as many notes as you want. Chapter 17 today is Karst and hydrothermal processes. Hydrothermal, Yellowstone. That's what I'm talking about. And we are still using McKnight's Physical Geography and Landscape Appreciation, put out by Pearson. Okay, Pearson Publishing. All right, takes care of that, and hopefully I don't get myself in any kind of trouble. All right, but that's the book we do use for the course. All right, so let's continue on. Karst and hydrothermal processes, solution, precipitation, caverns and related features, karst topography, and hydrothermal features. Ooh, I like it. All right, solution and precipitation, groundwater versus underground water. Of course, groundwater on top, underground under. And we're talking sculpting of the landscape, caverns and stuff like that under the ground this time. Water in its pure form is a poor solvent, okay? Water by itself is just water. It doesn't really do anything. It's all those other chemicals and minerals and things that are mixed in, okay? Carbon dioxide, iron, you name it. Whether it comes from rocks or it comes from the elements or it comes from the atmosphere, it's all the stuff mixed in with water. That's what makes water a good solvent, okay? And makes it dissolve, rust, and do the different things. It's because of all the stuff mixed into it, all right? Carbonic acid and dissolution of bedrock, all right? When you're talking dissolution, you're usually talking limestone and or dolomite, okay? So we're talking, you mix carbon, you mix water, and you put it in the right environment, and it will dissolve limestone and what have you, okay? So that's what this really is all about, this chapter. If you'll look, we have 6 elements, items here, whatever you want to call them. And one of the things you'll see on the test, so take note, is you have sodium, calcium, magnesium, silicon, iron, and aluminum, all right? If you'll notice, sodium dissolves best in water, so it's more dissolvable in water than any of the others. And aluminum is the least dissolvable. You might want to remember that. So dissolution, solution, precipitation, dissolution. First thing we got to do is we got to dissolve. We got to get all the excess stuff out, okay? So the most effective on carbonate sedimentary rocks, e.g. limestone. All right, and you do need to know this. You may see this again as well. Calcium carbonate reaction. So you got calcium carbonate, otherwise limestone, okay, plus H2O plus CO2. Those 3 things are what make that carbonic acid, okay? And we have the same thing with dolomite. Now here's the thing. Limestone is really soft, really fragile. Now if we'd gotten to go on our field trip like we were hoping to, you would have been exposed to gypsum and alabaster, okay? They're a little tougher. They're still soft. Don't get me wrong. They're still soft. You can cut it really easy. All right? It's soft rock. But it stands up more to the human touch. So like alabaster, it has to stay in a dark environment. Otherwise it gets algae on it. But you can at least touch it. All right? Limestone, stalagmites, stalactites, things like that, you can't touch them. The oil from your finger will break them down, okay? It can destroy them, okay? So you can't touch them. Dolomite, a little tougher, a little stronger than the limestone, but still, you got to be careful with it. However, if you look, dolomite is 2 of everything. All right, calcium, magnesium, H2, H2Os, 2 CO2s, and that's how we get that. So that's dolomite, 2 dolomites, 2 H2Os, and 2 CO2s. So remember that. Dolomite, 2 of everything, limestone, 1 of everything, okay? Only 3 things go into it. That's it. Water, carbon dioxide, and whatever element, limestone or dolomite. These are the most notable in the dissolution process, and that's because they break down pretty easy. Occurs more rapidly in humid regions. You got to have water, right? And if you put water with heat, now we're starting to get some things done, okay? So anyway, water, heat, humid regions, that's where you see these excavations really going on as far as caves, these beautiful stalagmite, stalactite type caves. Possible role of sulfuric acid. That has more to do with the hydrothermal features, and we'll see that a little bit later, okay? But sulfur comes from volcanic material, okay? We're talking, volcanoes, calderas, all that. We're going to get into hot springs later. All right, role of bedrock structures. So profusion of joints allow groundwater to penetrate. So we have joints, and it gets water into those joints, and it gets underground, and then it begins to dissolve, all right, all of that limestone and stuff out. Now, let's take a look at this, okay? First of all, what don't you see here on the top of the landscape? You don't see any well-developed streams, okay? Karst means barren land, barren, no streams. What little bit of streams or trickle water there are called disappearing streams because they run into these joints and then create sinkholes, okay? So, and it doesn't matter, they can be big sinkholes, little sinkholes, there's no size to them, depends on how big a limestone surface you have underneath, right? If I've got a big area, a big chunk of limestone under there, a little chunk, that's all that means, right? So, I want you to look at this. So, see, we got a sinkhole here, no water going into a sinkhole. In a disappearing stream, it's water involved, okay? And then we have our column. That's when a stalagmite and a stalactite connect together, okay? One from the roof, one from the floor. Stalactite, easy to remember. Stalactites hang tight to the ceiling. Stalagmites are on the ground because they might trip you. So easy to remember, right? All right, so mineral water trickles along the cave. First of all, let's go back. So profusion joints allow the groundwater to penetrate. It dissolves all that material out, okay? Now, it's still humid in that area. So what's left is dripping off the walls and the ceiling of the cave, creating these stalagmites and stalactites. So it's what we call reprecipitating, okay? Mineral water trickles along cavern, roof, or wall. The reduced air pressure precipitates mineral material. Environment, right? If you can keep something kind of in a localized environment from the outside elements, do all kinds of wonderful, beautiful things, okay? High mineral content present in hot springs. Lots and lots of minerals. However, hot water has more minerals, but except carbon dioxide has less carbon dioxide. Why is that? Well, first of all, just like we talked about the atmosphere in our pocket of air, right? Very beginning of the semester, if you expand it, right, it's less dense, right? Cold is more dense. Hot is less dense, which means it allows that carbon dioxide to get released and escape, okay? So, less carbon dioxide because carbon dioxide will escape when something is hot, okay? Remember, carbon dumps are the ocean, but when it's cold, it sucks it all in and takes it to the bottom and puts it in those sediments. But if that water's superheated, it's not keeping any of that carbon dioxide. It's like, because it's steaming and stuff, it's letting it all go. The gases are being let go. All right, caverns and related features, large openings beneath the Earth's surface that result from solution processes, okay? So we've had dissolution, now we're getting into precipitation. Often found in areas with massive limestone deposits, okay? Big deposits of limestone, because we can keep that precipitation factor going and create these beautiful features. Two principal stages: the initial excavation stage, okay, dissolution stage. The decoration stage, that's more of the precipitation stage, okay. Speleothems, so stalagmites, stalactites, columns, all these things are known as speleothems, okay, because they'd have to deal with limestone. So they are known as speleothems, karst topography, speleothems, okay. And we've already said stalactites tied to the ceiling, stalagmites might trip you. Columns joined together, and then we have soda straws. So it's a real narrow hanging off the ceiling that come down, and they're just really, really, really small in diameter, and very, how do I want to play it? They're very easily disturbed. You can't touch them, okay? They're very sensitive to everything, right? But anyway, there we go. I haven't been in this particular cave. This is the one in Carlsbad Caverns. I know there's one in Arkansas, and we'll talk about the one here in a little bit that I went to. Oh, there we go. It's time to talk about it. In-class prompt. Oh, must mean you might want to remember this. Take it, Cave of the Winds in Colorado. First of all, Cave of the Winds, Colorado. It's up at the top of the mountain. You got to drive up there. Kind of scary. It's like a 1.5 lane road that's two directions. Two cars, yeah, you look off the edge, it's a little spooky getting up to it. It's paved and everything. It's just real narrow. However, if you get an RV coming down it, you backing up, okay? It gets a little spooky when there's a big RV on there or whatever. You kind of got like two wheels on and make everybody lean to the inside, you know what I'm saying? Just to keep the weight on balance. But anyway, me and my kids went to Cave of the Winds up in Colorado and got to take some pictures. And this here was one of the features there. And this was known as the heart of the cave. All right, so this had, stalagmites, everything around it, but it was a little bit different color. Now, let's talk about where it's at, okay? Colorado Springs up in the mountains, right? Wait a minute. Limestone is usually a feature that is associated with oceans, inland seas, okay, like alabaster and gypsum, okay? It's a deposit that's usually in oceans. It's an evaporite, okay? Wait a minute, it's in the mountains? It's high up in the mountains? How can the ocean be high up in the mountains? Well, that goes back to some of those questions about, hey, there's a lot going on in the Colorado Rockies, okay? A lot. Very confusing, lots of hypotheses, but it's kind of in a world all its own. All right, so karst topography. Here we go with a little bit more. Topography that results from underground dissolution. Again, dissolve, move it away, right? Some typical landforms. Here we go. We're going to underline some of these here. We got our sinkholes, right? Now, sinkhole is also known as a doline. Write that down, D-O-L-I-N-E, doline, right? So a sinkhole is a doline. If you have a bunch of dolines and they collapse, they are known as collapsed dolines or uvula. There's uvula. Okay, that means you got more than one. So now you got to remember, how does all this work? Okay, well, first of all, let's look down this bottom one right here, okay? The land at one time was all the way up here, okay? Landscape. And the water gets down those joints, it dissolves out everything, and the land around it sinks down. Okay, that's how this works. Okay, so as you see, flat up here, and then it starts dissolving everything out underneath, and look at our landscape. It begins to change. All right, so it takes and it sinks down. All right, and then that's when we can actually get some well-developed streams once it reaches its base. Okay, so there's our well-developed stream. All right, so we get this dissolution going. You get sinkholes going and things collapse. And that's because once you take the water or minerals, whether it's salt, whatever, anything that is supporting that land, once you take it out, the weight of the above ground, the weight over above it, if it's too heavy, it's going to collapse. Okay? So we see sinkholes and stuff, and we'll get into that a little bit more, but we see sinkholes and stuff everywhere. They take a bunch of salt out of Kansas. There's big salt deposits and caves up there. They've had collapses of those caves. Why? You're taking everything out. The ground above it's too heavy. Okay, so same issue here. Okay, so we have sinkholes, we have dolines, we have uvula with collapsed dolines. Another word here, right here, haystack. Okay, this is tower karst. Remember, karst means barren land. Tower karst, or haystack hills and mogotes. What are those? Those are leftover remnants, okay? Or maybe they are a different material or substance, rock, whatever you want to call it, okay? Because this says there's some shale right there, okay? So shale is less dissolvable than the surrounding landscape. But for the most part, just like right here, you can see there's still some limestone in there. For the most part, this is the stuff that didn't dissolve. Maybe it was just a little bit harder. Remember, differential weathering is just like everything else. Water takes the path of least resistance, and those rocks that are more susceptible to erosion and what have you will go first compared to those that are less erodible or more resistant, okay? Some other things we have here. So we got our sinkholes. Oh, let's talk about our disappearing stream. So if we have a disappearing stream here, right, okay, that is also known as a swallow hole. Swallow hole, so remember that. Sinkholes, dolines, uvula, swallow holes, disappearing stream, okay, haystacks, mogotes, tower karst. Lots of words to remember. Write them down because you're going to see them again. 10% of all land surface is soluble rocks. It's one of the smaller ones, but it's pretty spread out all over the world, okay? All right, so sinkholes, that's the big one we see. You got to have sinkholes because you got to have some way for the water to get underground. Okay, so you got those joints, water gets in, starts creating that sinkhole. Right? Again, if you would have went on the field trip a couple of years ago, we were standing around the parking lot and we noticed a small sinkhole. I'm like, is that a sinkhole? And the guy goes, yeah, I think it is a sinkhole. We got done with our tour. We headed back that night, and sometime around 1 a.m. or so in the morning, the cave system collapsed in. It ended up that we were right. There was a sinkhole there. Water had gotten under the parking lot, had gotten down one of those joints, and had been eroding for a very, very long time, and nobody knew it. The little sinkhole sometimes doesn't open up until, again, that overbearing ground is too heavy and begins to collapse in. So now, if you go on the trip of the caverns there, Alabaster Caverns State Park in Oklahoma, you have to go through the back door, and they'll take you as far as they can, and then go back out the way you came in, because there's like 300 million tons of dirt or something like that they got to get out of there. All right, so sinkholes, most common. Okay, rounded depressions that form from dissolution of surface carbonate rocks. Again, dissolution from underneath, overbearing rock, boom, splash. Right, wide range of sizes. Again, it depends on how big the formation of limestone is. Is it a big formation? Is it a small formation? Okay, how much limestone's there? I mean, limestone, it's not like you just go in, there's a big square block, and we're going, oh, we're going to dissolve it. No, underground topography. It's got bridges and humps and caves in itself and all kinds of stuff, okay? So it's rolling and what have you. There's big, small, it's underground, but it's just like what you see on top of the surface, right? There is well, I'm going to say no, but there's not a whole lot of just straight up flat areas. Most everything has a little topography to it. All right, fundamental Karst unit of erosion and weathering. So you got to have the sinkhole before you have anything else. Chains of sinkholes are known as uvula. We already said that. Tower karst, mogotes, haystack hills, and then disappearing streams are swallow holes. Okay, now talk about this guy's house. This guy's got the best house in the world. If you'll look, he's got a swimming pool right here in the backyard. Boop. Okay, and he has a swimming pool in the front yard. Walk off your porch, splash, right? It's all good. Now, I'm sure he didn't like it when it happened, but we find these a lot in Florida. And why is it? It's because you got water in the East Coast, you got water on the West Coast, you got swamps and stuff in the middle, and you got underlying limestone. And again, you pumping water out, whether it's being pumped out for human consumption, whatever, the overburden ahead, above, boosh, in you go. Okay, but I love this guy's house. I'd like to have it, Now, don't get me wrong, he needs to shore it up a little bit here. He doesn't want to lose the house. But wow, you know what I'm saying? Put a ladder in there to crawl out and crawl in, you just go swimming. So here's our karst topography. As you see, it's pretty spread out over the entire world, over the entire Earth, right? You don't just find it in one spot. It's a little bit everywhere. All right, hydrothermal features. We know I love Yellowstone, right? I want to be there when that bad boy goes off. Be the best 0.12 seconds of my life, right? Because that's about all it's going to last. But I'll be able to go up, and that's it, right? But anyway, you know I love Yellowstone. So hydrothermal activity. Now we're talking geysers and hot springs. Okay, so hot springs, water heated by magma forced upward from pressure resulting from the heating. So if you'll notice, we got our water here, right? It's a pond of water or pool of water, and that water makes its way down through these joints, right, through the pipe, until it gets close to magma, and that magma heats that water up, right? Now, depending on your vent tube here, right, if you've got a big pocket of water here, right, and it's superheated, once it gets to pressure, that's when you start getting geysers, because all that water there gets forced right up and out. So we're talking about these geysers versus hot springs, right? Some of the resulting topography from hot springs, again, we got a little bit of dissolution and stuff under there, and it spits all this stuff out, so we'll talk about that. Algae growth. If you ever go to Yellowstone, one of the most beautiful things you're going to see is the algae. I was more impressed with the algae than I was all the geysers and stuff. You've got blues, and bright yellows and greens and reds and blues, and it's just gorgeous. Algae grows in that warm, wet environment. It's perfect for it. And it is beautiful, okay? Absolutely beautiful. Now, let's talk about these hot springs and stuff, because here we go. Never fails, and I'm telling you right now, if I ever see you on TV talk about it, nobody told me, I'm going to be like, I did tell them. I told them, and they didn't listen. Folks, every single year, somebody doesn't either have no common sense, don't understand no science, something, but somebody dies every year at Yellowstone. Why? Because they don't follow instruction. First of all, they got paths going all the way around these geysers and through all these different little hot springs and stuff, and it says stay on the path, right? And it's a man-made wooden path, so it's easy. It's not like it's a couple of rocks out there. No, it's easy. Stay on the path. But you always got that one person, and I would use another name for that one person, but I'm not. We're going to keep it clean. But you always got that one person that goes, oh, I wonder if this is really hot. Okay, first of all, it's steaming. It's steaming. It means it's a minimum of 212 degrees. And so what do? They take their shoe off and they stick their foot in there and they pull back bony toes and stuff because the hot water has already eaten all the meat and pulled the meat off their foot. And they die from shock, right? Can't get them to the hospital soon enough. Okay? Happens every single year. You get that one person, oh, I wonder if this is hot. If it's steaming, it's hot. It's a minimum of 212 degrees. It's probably a lot hotter than that because it's associated with a magma chamber. Come on, we're talking something that melts rock. Okay? If it melts rock, it's going to melt your foot. So stay on the path, okay? Don't be that person that I have to say, oh, I told them and they didn't listen, right? Just remember that. So geysers, or intermittent hot springs. I already kind of told you how they happen. They got that pool of water, gets superheated, shot up through the pipe, right? All right, so accumulation of superheated water and steam builds pressure. And when the pressure builds up, tremendous heat required, the geyser formation, once that pressure builds up, it blows. Okay, now this is Old Faithful there at Yellowstone, all right, which is not as faithful as it used to be. They've got a lot of tectonic things going on there. Again, thinking maybe we're getting close, but Old Faithful's not quite as faithful. We'll talk about a little bit more about Old Faithful. Variable eruption times. Most of them go off at different times. In fact, I want to say it was called Wagon Wheel Geyser, I think, when I was there. Hadn't went off in like 212 years, and it went off. Everybody's like, whoa, that thing hasn't like erupted in 212 years. Well, it did while we were there, right? Variable deposits. Most are sheets of deposits scattered irregular along the ground. So you get this little tephra type stuff, and that's that precipitation from the material that's being washed or blown out of the geysers. Now, it's really cool at Yellowstone. I didn't think the geyser that was that cool. Okay, I went off a couple times. Yeah, so faithful. Okay, see it all the time, you know, on TV or whatever. Oh, no big deal. What was cool to me was there's this big group of ducks. And so when the geyser's dormant, right, it's not being active, right, these ducks go all the way up to the top there, and they'll sit down on that warm ground, right? And they'll sit there, and then they'll get up, and they'll walk back down the hill, and the geyser goes off, geyser goes down, ducks walk back up, sit down, ducks get up, walk back down the hill, sit down, geyser goes off, geyser goes down, and they do this all day, and you're like, that's a workout. Just pick a spot, but it's kind of cool. I liked watching the ducks more than I did the geyser. All right, fumaroles. What are fumaroles? Surface cracks connected to deep-seated heat source. Otherwise, basically a sinkhole that goes to the magma chamber. Here's the thing, little water drainage. There's no water associated with it. Now, again, everything. Please remember, when you go to Yellowstone, you are around, you're in it, however you want to put it. You're being associated with a volcano, okay? It's a volcano, and volcano is molten rock. Please remember that. If it can melt rock, it can melt you, okay? You're not, you know, some kind of steel person. You're a human being, okay? You can melt. And the reason I say that is little water drainage. Okay, so fumaroles don't have any water in them like a hot springs or a geyser, right? They're a pile of superheated rocks that have a magma source or a heat source coming up to them, okay? And the only water that gets to them to make them steam is this surface water after a rain or something. Snow melt, something like that, okay? As long as it's got a water source, it'll steam. But hey, what if we get to August? You know, middle of summer type thing? Guess what? There's no water, there's no steam. And you will see people go, oh, there's no steam. Mr. Cox told me there's no steam, so the rocks must not be hot. No, the rocks are still hot. You just don't have any water for steam. So don't go up thinking, hey, I'm going to go touch the rocks. Leave the rocks alone, okay? It's a volcano, okay? Remember that. You're in a volcano, right? So water that is drained is converted to steam. Steam issuing vent, either continuously or there's that big word, sporadically. Why? I've got to have some type of surface water to fuel steam, right? And when I was there wasn't any steam on fumaroles, okay? They were just big piles of superheated rocks. So some of the hydrothermal features at Yellowstone, 225 geysers, volcanic bedrock materials, okay? Shallow magma chamber, mantle plume, heat source, hot spot, don't forget that. Copious summer rain and winter snowmelt are your water sources, okay? Tell you in late summer. Numerous fractures of weak zone from earthquakes. Remember, there's a lot of tectonic. In fact, the lake is lifted up on one side and dropped on the other. There's a lot of tectonic stuff going on at Yellowstone, especially in the last few years, okay? So some of the hydrothermal features here. Geyser basins in the same one. Geyser basins, same watershed on the west side. Geyser basins are drained by 3 rivers. There's some rivers in here. One of them, the big one, is the Fire River. Okay. Geyser basins have extensive geyserite. That's that material that gets precipitated out, geyserite. And then Mammoth Hot Springs has terraces. That's some, I wouldn't call it tephra. It comes out and it's really, really pretty. And it's got all, because you've got all those minerals in it, it's oranges and rust colors and all kinds of colors. Real pretty, but they're huge formations, right? So Mammoth Hot Springs is a little bit different than the rest of the park. Now, how's the park set up? Well, first of all, it used to be one big circle, right? But now they've got it set into the upper ring and the lower ring, okay? So it takes about 3 or 4 days to hit all these features. But they've got it now. They put in some new roads and what have you, make it a little easier so you can circle around and hit everything, okay? So you got the upper circle, ring, whatever you want to call it, and the lower ring. Now, down here is where Jackson Hole is, okay? It's down there, right? Now, when I went to Yellowstone with my kids, somebody asked me this. I actually asked, I didn't mean reservations for a motel. What do you do? Oh, no, you should be fine. Okay, and I got there. We checked every little motel, hotel, trailer house, shanty, cardboard box, and an alley. And the cheapest thing we could find was $225 a night, and it looked like you were going to take more away than what you brought. So I was like, no, we ain't doing that. So we decided, you know what, we'll camp out or do whatever we need to do. We're here, we're tough. So we decided to go on the upper circle, and we started around that. And then I noticed there is a gate. The main gate's down here, but there is a gate out here as well. I went, oh, well, let's go out the gate and see what's over in Idaho. And we're driving through there, and yeah, there's some motels right there at the very beginning, a bunch of them. But again, $225 a night. And I kept cruising down the road. I'm like, surely there's got to be a small town or something out here. Well, I keep cruising. Got about 30 minutes, maybe 45 max. I want to say it was 30. But about 30 minutes down the road, and I noticed all of a sudden there's like these cabins, like rental cabins. I'm like, oh, pull in there. Okay, cool. Get in. I asked the guy, I was like, hey, who do I see about renting a cabin? He goes, well, we usually don't rent them out. He goes, we're open during the hunting season. He goes, this is a hunting lodge. I was like, oh, okay. I said, well, I was going to rent a cabin, so, if it was a decent price. He goes, I never thought about it. How $45 a night? We had a cabin, full kitchen, whole works, $45 a night. 30 minutes into Idaho. So if you go there and you don't have a reservation for one of those expensive cardboard boxes in somebody's alleyway, go into Idaho. You can find a place, okay? Oh, another in-class prompt, too, with this chapter. All right, first of all, these are some pictures we took around the Yellowstone area. Columnar basalt from a last Yellowstone eruption. If you will look, now, I couldn't get close. This is kind of across a valley here. But that's like 20, 30 feet thick. I mean, it's a thick formation, right? And it's columnar basalt. So think, the last time that Yellowstone erupted, right, it put down that much lava, folks. I'm 5'10". Think about that, 20 to 30 foot of lava on top of me. What? Yeah, you're not getting away. Remember, doom, gloom, despair, death, and agony on me. If Yellowstone goes off, if you're close, you toast, okay? And then I consider myself a photographer, which I'm not. But I tried to sneak up on little animals and stuff. I can get pretty close sometimes. So I tried to sneak up on this bear here and get his picture. He was not impressed with me whatsoever. He was worried about getting some grubs, and he just kind of wandered on his way. But hey, I got close enough to get his picture. This is the picture I want you to remember right here. Okay, for your in-class prompt. This photo is an important one. Look closely. This is me and my kids on Mount Washburn. It's the fire lookout at Yellowstone National Park. So they got a fire lookout. It's kind of a historical thing now, but you can go up the side of the mountain ain't that tall. I think like 18,000 feet, something like that. Not that tall. You'll have to look to see how close it is right there. But anyway, went up the top of the mountain. Now, none of you have ever been mountain climbing. First of all, let me tell you something about mountain climbing. You just don't go straight up. Okay, there ain't no path going straight up. No. Okay, so you think, oh, 15,000 feet, that's not even 3 miles. No, it's more like 25. Okay, because when you go up a mountain, it's switchbacks. By the time you get to the top of the mountain, you've walked about 25 miles. So we got up there. It was cold. It was windy. And we were plumb out. And then we looked and we were like, oh my God, can we just roll down this mountain or do we got to walk back down it? I have to admit, going down was a whole lot easier than getting up, okay? And it's not the only mountain. Me and my kids have crawled up, I shouldn't say climbed, we crawled up a couple. But we got to hit it, we got to try it, right? So anyway, did a little mountain climbing there, okay? So anyway, if you ever go hiking, give yourself plenty of time, okay? Don't think of it as, oh, I'm going to get up this mountain in 2 hours because it's only a couple miles. No. Start out in the morning. And the last thing you want to do is be on a mountain in the evening time, because that's usually when the rainstorms come through. And guess what? There's iron in the mountains. And guess what? Lightning's attracted to it. And so if you're on the top of the mountain, there's a good chance you're going to get hit by lightning. So the old story, get off the mountain early, okay? Because you don't want to be there when those evening rain showers and storms come through, because you'll get hit by lightning, okay? So take that. There's your safety brief for the day, all right? All right, that's it for chapter 17, right? I'm going to get this saved up. I'll get it posted. It's all good. Tell you what, have a good day. I'll see you on chapter 18. Peace. See you on the flip side.